We'll be talking about how to manage cognitive load in data-intensive projects. And to quickly explain cognitive load, so it's the amount of information you have to keep in your working memory in order to be productive and efficient. And you'll be hearing a lot this term cognitive load, and I really hope that you will not get tired by the end of it. So before we start, let's do some short introductions. So I'm Arne. I've been at Thoughtworks for about 2.5 years. Originally, I come from Estonia, and now I'm in Spain. And
my name is Melania. I'm based in Barcelona office. Been working there for 3.5 years. I'm from Spain. Yeah, let's start with some more interesting facts. So we decided to do this talk together because we actually worked in a data project together. This is a picture of us on a climb because also we are mountain lovers and we go climbing together in Barcelona mountains. Let's go quickly through the agenda of what we are going to share today with you. And so we're going to start with some introduction on what are the issues that we actually find on data-intensive projects, on data engineering projects. And also, we want to share with you an example of a project to make it easier to talk to you about what are the issues. In case you don't have experience working on data projects, then we will share our experience on how we actually solve these problems. And yeah, at the end, summarize it on how this reduces cognitive load. So let's start on what is a data engineering project. So at the end, it's just a way of getting information from a source, from an input source, applying certain transformations that give some particular business value to this information, and then store it in some other place where it's going to be used by whoever wants or needs to use it, right? Looks very simple, so where is the problem? We want to share here which are some of the subdomains that are part of usually a data engineering project. And so we have sources, ingestion, storage, transformation, querying, and observability or analysis on this information. And just to go through one of the examples on these subdomains, let's talk, for example, on the transformation tools that you can use. So you can use Spark or DBT, and if we focus on even on Spark, you have many different ways of working with it, because at the end it's a multi-language engine that it needs another language. So you can use Python, Scala. Also, you need to link it to some kind of a storage system. So very complex.
As you might have gotten a sense, we think that being in a data engineering project is a little bit difficult. And we're saying this for the following reasons. So we think that historical data is a bit different. There's way too much tooling available, and it's all a bit confusing. The industry hasn't quite matured yet. And finally, the age-old topic of collaborating between different roles. And I'll explain a bit each one of them a bit more. So first of all, the data with which we deal with in a typical analytics project is a bit more different. So first of all, we have a lot more of it, right? And the transformations that we have to do are also a bit different. We have to ask ourselves really often like this really simple question, such as like if we see a customer ID in a particular table, what does it actually mean? Is it the same customer ID that we see in another table? Can we join on them? Do they mean the same thing? Does a null in this column break the pipeline or not? So yeah, we have to keep like answering these questions. Second of all, like Melania was already saying, there is a lot of tooling out there. And it seems that every day there's a new startup getting like another 20 million euros to come up with another orchestration tool. And yeah, apart from just, you know, the existing subdomains getting new tools, there are also like new subdomains popping up. Like data governance is becoming more and more important. We have to deal with security, privacy, and so on. And the tools that we have available, we don't just have to understand them, they also have to integrate together so that there would be a cohesive solution that we provide to our clients. Third of all, in our opinion, the industry hasn't really matured that much yet. All of the data projects that we've been in, it feels that we have to start things from scratch. It doesn't seem that there are that many patterns available. Another thing that we have noticed is that each time we approach like a particular business unit of a company, so for example, a marketing department, whenever we want to help them with data, it seems that we have to do everything from scratch. Like it doesn't really seem that there are that many like bootstrapping patterns available for us to get, moving really quickly. And yeah, if anybody has a different opinion, please reach out to me because like this is a topic that really like blows my mind. And I would really love to figure it out. And then finally, collaboration. So it took software engineers like a really long time to figure out how to talk properly to UX designers, to QA engineers, and so on. And it seems that in the data world, we're kind of experiencing the same problems, right? Like it seems that data engineers can kind of talk to software engineers because we're basically doing the same things. But then talking to ML engineers, data scientists, and so on, things become a little bit more difficult. And it seems that like the question of can I put this Jupyter notebook into production will never actually go away, even though the answer is always no. Like we can never put a Jupyter notebook into production. So how does it actually manifest?
Yes, so now we want to show you an example. Sorry in advance because it's not a real example. We came up with this scenario, this hypothetical client. So let's imagine that there's a grape farm cooperative that has been collecting data for many years. They are a very state-of-the-art organization, and they want to use this information to get better decisions on, for example, how climate change is affecting their production. So they decide to focus on a first metric, a first information that it's getting the ranking of the most affected farms all around the world in order to be able to apply good solutions specialized on each of the regions. So they contacted the data analyst team and they came up with all the transformations needed to get this metric. Let's imagine that it's in a Jupyter notebook, and disclaimer alert, this actually happened in one of our projects. We received the information on Jupyter notebooks, and now it's the work of the data engineers to put this into production. Let's imagine that this is more or less the data flow that we can find just to get information for this particular metric. So we extract the data, we partition it somehow to make it more efficient, and we then apply the actual transformations that were in this Jupyter notebook that we received, and then we present it. But some problems happen. So at the beginning, we realized that the actual transformations that we applied were not exactly the same as the one in the Jupyter notebook. We didn't copy-paste it, right? We were applying TDD and this kind of ways of working that we usually apply in software engineering projects. So we realized about this. We fixed them, but then also we realized when we present this to the farmers that the actual accuracy of these metrics is not good enough. It's a problem that we experience in one metric, but now let's imagine that the farmers want to get more metrics. Even though these problems, they really like this kind of system, and they want to know, for example, what is the soil quality or how insects affect their production. So we have 10 metrics or 100 metrics, and this is what actually a system looks like in some of the projects that we have worked on, in some of the organizations. So it starts with few metrics, but at the end it escalates really fast. And the problems that we were having about not having accuracy, or problems between the transformations that we actually have in the productionized system, multiply by 100 or by hundreds. So we want to share with you a collection of themes that we find that can tell us when we are having this issue. Because of course it doesn't have to happen in all of the projects, but how to realize when we are reaching this point that you're gonna have a lot of problems managing the knowledge. So when you have to work with many teams, if the pipeline fails very often, you also have to fix these problems on many metrics, right? And then also when the data ownership is unclear, and finally when it's taking very long to build a new metric. And how can we solve then all of these issues, Arne?
Cool. So this is basically the crux of the talk, right? So what do we do about it? The advice that we've kind of like gone through and that we've internalized, we've divided it in 3 different sections. And they all kind of cover different levels of organization, right? So we'll start with more organizational, then how to deal with knowledge, and then finally, what are the good practices that each developer can do. And we'll start with the first pillar of taking some of the advice that we have from data mesh and Team Topologies, and how would they reduce the cognitive load of the team. So first of all, data mesh. Maybe everybody here already knows what data mesh is, but if you don't, it's a decentralized socio-technical approach for making sure that your analytical efforts can actually scale. And it relies on 4 different principles. So first of all, your organization will have to become domain-oriented and be split among domains. You should start treating your data as a product. All of this should be enabled and helped by a self-service platform or self-service tooling. And finally, there should be a bit of data governance sprinkled on top of everything just to make sure that nothing goes really wrong. Then the second kind of methodology that we've found helpful is the advice from a book called Team Topologies from Matthew Skeleton and Manuel Pais. And the advice that comes from there is to really focus on stream-aligned teams so that your product teams could actually focus on similar things. Again, we have this idea of having a platform team that kind of helps accelerate the product teams. And then in the end, we have a bunch of enablement teams making sure that innovation actually flows into the stream-aligned teams. And how do these ideas actually help to reduce cognitive load? I think we've all kind of been in projects that start out with a good idea that's not really business aligned, right? So like you build some cool tech, but it doesn't really go anywhere. And one of the core ideas of all of these methodologies is to really focus on what is the business value, what are the things that we're building, and focus on things that make sense cohesively, right? So you have stream-aligned teams building things that make sense together. There is also a clear ownership of products, which kind of makes it a bit easier to discover what's going on in the organization, take advantage of existing things, and then building on top of the products that you have. And finally, this idea of having ready-made platforms that help you speed up your work, right? Like that helps eliminate a lot of the information that you have to keep in mind if you can just use something as a service. So now the second pillar of automating some of the knowledge management.
So now we want to share with you in a team level how can you manage the knowledge that the team has, and the best way to do this is with documentation and of course automating it as much as possible. And we want to share with you how to manage the knowledge, and we will go through all the documentation that is available in terms, to help you do that for data projects, apply for data projects. Get comfortable because it's a long list, as you might imagine. Let's start with the... no, we are kidding. Let's talk just about a couple of use cases that we have more experience on. And we came up with these 2 use cases, so keeping track of the data and making sense of the data flow. So I'm going to start talking about making sense of data, and I want to go back to the example that I shared with you before about the farmers client. So let's imagine that with these 100 metrics, they decided to hire more teams to work together. The problem here is, well, you have to know what is that your team taking care of, so what are the metrics that your team needs to produce and maintain, but also you need to know which are all the other metrics that the other teams manage, because of the dependencies that you might have, because you might be using also the other people, the other metrics for the ones that you produce. And so this kind of dependency maps can help you a lot to visualize very easily which depends, which are your dependencies and who is the team that is taking care of this. And also, even you can include information on some metrics that maybe nobody is managing for any reason. The team stopped working, someone left the company, these things happen, right? So this is a real example of something, well, not the real information, but we actually built manually a diagram similar to this one in one of the projects. And this is a manual way of doing it. In a second, we will share how to do it automatically, but just to share with you options that you have also if you cannot implement the automatic way. And then another way to keep track of data is related to some other issue that we have. So let's imagine that you are the engineering team and you wake up a morning and there's a data pipeline failure. So there's one of your data pipelines is failing, right? And it's strange because what it's saying, the error is that there's some kind of misaligning with the schemas. And so this pipeline, let's imagine that it was already in production and the contract was already agreed, but you realize at the end that so the team that was taking care of one of your input sources changed the contract of the input. And it was not communicated. And the problem of this situation is also being able to, on your own, check somewhere the actual schema that you should be expecting. And this was a real issue that we had because, of course, we didn't have access to their system, but we also didn't have any kind of like a system or documentation system where we could check it by ourselves. And at the end, it was as simple as an ID we were expecting as an integer, but it was a string. So yeah. And the way to document this information is with data catalog systems. So this it's an actual example of how data catalog looks. So you can document the information for each of the sources that are part of that data system, putting there all the schema information, but also specific information for some fields, like for example, timestamps. I'm sure we all have experienced some problems with timestamps, and you can include information like, for example, here saying that you are using UTC time. And this is also a way to know who's taking care of each of the sources and doing it in an automatic way.
So Melania was kind of giving an overview of how to keep track of data or how to make sense of data. And now I'll cover the second use case of how do we make sense of how the data actually flows inside of the system. And yeah, I think we've all kind of been there, or like at least I've been there many times because I kind of have a good memory for details. And the situation is that you have a bunch of different pipelines, like around 10, 15, maybe 100 pipelines, and all of them kind of work at different intervals, right? So you have data arriving at a bunch of different times, and business like keeps asking me as a developer, so when does a pipeline A finish, can you create another pipeline that actually depends on that pipeline? And you kind of have a lot of little details, such as like, where are you storing your data? At what time does it arrive there in your memory? And that's a bit problematic, right? Because you can have a lot of different problems with that. You can construct a new pipeline that depends on a previous pipeline, but the data hasn't arrived there yet. And for that, we have this really simple diagram that we've kind of already showed, where we can make it really explicit. Where is our source data stored? Do we store any intermediate data? Where do we keep it? And where does the destination data end up being? And you can even add like more details on this diagram, like what is the actual S3 bucket where you're storing all of your intermediate data. And the second nice thing here is that you can also kind of put the information about data freshness here, like what time is my pipeline starting? What time is the intermediate data arriving? What time is the final data arriving? Things like that. And that really helps you to talk with the business folks about the dependencies between the different pipelines and make it really explicit to everybody, like what is the state of freshness with respect to arrival times in the system. The previous slide was kind of showing how to do it manually, how to kind of visualize the data flow manually. And again, to automate this, we can again use the data catalogs. And almost all of them have this really nice lineage feature where you can plug in your data sources, your pipelines, and all of the metadata about how the data flows in your system goes into the data catalog. And you can visualize it really easily, like how does the data flow from one data product into another one, which orchestration jobs are taking care of it, and so on. And that really, again, allows you to save some manual work and make sure that everybody has a visual overview of how the data travels in your system. If we go a bit deeper, we can have many data engineers working on many different metrics. And how do we make sure that all of them actually, write the code in a uniform way? And what we've discovered, and this is actually quite reasonable, what helps is to extract some patterns from your code and document these things. And here we're trying to convey like a really simple diagram that shows how are we building different metrics in our system. So we're documenting that we're doing some extractions, we're applying some transformations, we're storing the intermediate data somewhere, then we're doing some joins, and then finally we're putting the final metric somewhere. And the nice thing about this is that not only will the developers kind of develop everything in a uniform way, this can also be a starting point for introducing some automation into the system. Like you can start building some DSLs to create some scaffolding, so that eventually, like all of the files for the components that you need can automatically be generated, and then you just put in the code that you need to actually create that specific metric. And when we go into the final level of how the developers code a metric, you can ask yourself, like, the business wants me to calculate a metric that shows the acidity in the ground where the grapes grow. How do I actually do that? What are the data sources that I need, and how do I transform the data for it to be meaningful? And we've kind of thought about this analogy with how a UX designer would document the flow in the system, like how a customer goes through your website. And the idea here is kind of the same. Like a data analyst can actually document what are the data sources that you need, how do you transform them, like you do a left join, you do a right join, how do you filter the data and so on, and eventually, in which format do you store it? The problem with this is that it's a very expensive way of conveying this knowledge, right? All of this requires tons of work. And quite often the amount of effort that you would have to put to create this diagram doesn't really, give the value that you could get from a developer simply figuring it out. But we do get a bunch of benefits from people actually putting in some effort into documenting these things and automating all of this knowledge gathering. So first of all, we kind of have a live view of the system, like everybody's on the same page of what's actually happening. Second of all, we do have better discoverability as well. We can actually see in a data catalog that we have a data product that does this thing that I need it to do, and I don't need to build it again. I can just take it and start building on top of it. And finally, since we're all kind of speaking the same language when we're documenting things, the collaboration between different roles will also hopefully improve. And now, the final pillar of our advice.
So we didn't want to forget about good practices and code design, because at the end it's a software system, and so we need to apply this. And I want to start sharing just an example of my experience when I was entering the team that we worked together. So it was a project, a data engineering project that was ongoing since a year and a half, so there was already a lot built. And actually for this project, we had to build the infrastructure also by ourselves, meaning the orchestration of the data pipelines, how we were also storing the data, and of course the metrics, the transformations, and the partitioning of the data. So for this reason, since it was a project that was growing exponentially, there was a mix of information in the code, and there was not a clear structure. So I realized, so why not applying clean code architecture also to data projects? And so I guess this image is familiar to you, and at the end the only difference that we have is that in the different layers, the core layer, so the one that contains the use cases and the domain model, in our case is going to be the data that we have produced, so the metric that we have produced that has the business value, and of course the transformations and business rules. But then the rest, we can apply the same abstraction, so a layer that contains all the infrastructural parts, so the orchestration, storage, loading, and yeah, the consumers are going to be different. In this case, it's going to be machine learning engineers or other data analysts or salespeople, but very similar. We want to share with you an example of the structure, the folder structure for the code, because this is not just saying that you are applying killing architecture, you have to actually organize your code like this. So for someone like me, starting in a project also is going to be easy to understand what is the data project about. Yeah, just want to quickly share with you. So we would have a layer with the core, so the metrics, and then it's super easy for someone new to see what is the actual business value that you are giving with this data project. And also then extracting and decoupling completely all the infrastructure. So of course the things that we have in any software project, so logging and observability or continuous deployment, but also the particular things for a data project, so like the orchestration of the data pipelines. And finally, of course, testing and the presentation. So here would be how do you actually present the data, so which file structure or schemas you use for the final output, and which are the benefits and how this helps reduce cognitive load. So I think we all know this, but just to stress it, it's for the technical team, it's really easy to see the actual value that we are giving with this data system. And also we decouple the infrastructure, so again we can focus on the business value, and potentially also applying some kind of tools that help us create new metrics in a very easy way. And for sure, reducing documentation as much as possible. With a good structure in the code, you need less documentation.
So finally, to start summarizing, we've talked about 3 pillars. So data mesh, automation, and good practices. What do they all have in common? They help us reduce cognitive load and make the teams a bit more effective. And they're doing it on multiple different levels. So on top, we have some organizational principles that really allow your teams to focus on the specific business value that they're delivering. And by applying this advice, we can kind of start getting rid of some of these centralized teams that have to do everything in the organization and that have to manage a lot of knowledge. Then we have automation, and especially automation of knowledge management. And that makes it really, really easy to gather all of the knowledge in one place, make it accessible, and make sure that everybody has the same access to all of the same knowledge. And finally, we have the good practices that we've actually known for like 25, 30 years, but we sometimes forget when we transition into a new domain. But this hasn't really changed that much, and it can still be super helpful for actually making sure that when a developer needs to create a new metric, they can immediately go into the code, start coding it, and delivering value quickly. So thank you, and if you have any questions, we're here.